Glucose is an energy source for your body. That is, glucose is oxidized to release energy. Now, that oxidation you could do on the benchtop. You could burn glucose in oxygen and it would release energy. In your body, it's done via enzymes and the reaction occurs at body temperatures. But the initial glucose and oxygen and final products, carbon dioxide and water, are about the same in about the same states whether you do it on the benchtop or you do it in your body. So if the initial and final states are the same, we know that free energy and enthalpy and entropy changes are the same. They're state functions. So the same amount of energy that you release on the benchtop is available to your body when you oxidize glucose in your body. It's a formal oxidation reaction. I'll draw out the molecules here. Here's glucose, and glucose is a cyclic molecule, so rather than drawing it as a ring, I just bent this bond all the way around to show that this carbon is attached to that carbon. Here's oxygen, carbon dioxide, and water. And we know how to assign oxidation numbers from Lewis structures. So let's look at the oxidation numbers. Here's a carbon in the glucose. This carbon, to determine the oxidation number, I assign the electrons to the more electronegative element. So oxygen gets these two. Carbon and carbon here, that's the same element, so I'll share these electrons and assign one to this carbon. And carbon is slightly more electronegative than hydrogen, so I'll assign both of them to the carbon here. So I'm assigning 1, 2, 3, 4 electrons to the carbon based on relative electronegativities. And carbon normally has 4 electrons around it in its valence shell, so it has oxidation number 0. Over here in carbon dioxide, we do the same analysis. We say, well, the Lewis structure, I assign all the electrons to the more electronegative element. That leaves 0 electrons around the carbon. And compare that to its atomic state, where it normally has 4 electrons. Then I see that it has a +4 oxidation number here. So it goes from 0 to +4. That's an increase in oxidation number, formally an oxidation. So something has to be reduced. If there's an oxidation, there must be a reduction as well. Here's elemental oxygen, where the oxidation number is 0. And what about the oxygen over here? The oxygen in water, I assign all the electrons to the oxygen. It's the more electronegative element. So it has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. The atomic oxygen would have 6. So it has 2 more than it normally has as an atom, so that's an oxidation number of -2. Indeed, that's a reduction. I go from 0 to -2. A reduction in oxidation number is a reduction. So formally, a catabolic redox reaction is performed in your body to release energy in the oxidation of glucose.